Hello, this is Tom Cardenas with California Surveying and Drafting Supply. Today I'll be talking about the 4 essential tools for processing 3D point cloud data within Trimble RealWorks software. In this presentation, I'll quickly cover the standalone segmentation tool within Trimble RealWorks version 7.1, the sampling tool, and specifically the topography-based sampling tool to get rid of any vertical noise from a point cloud, the cutting plane tool and how to project planes onto your point clouds, and the 2D EasyLine tool for creating polylines over your point clouds. The area of interest in this project is an overpass with obvious noise from traffic passing the scanner throughout the 3D scanning process. Our office objectives are to segment areas of interest using the standalone segmentation tool, to clean up noise or unwanted points produced by vehicles passing the scanner during the scan using the topography-based sampling tool, to use the cutting plane tool to help visualize cross-sections of a 3D object, and to use the 2D EasyLine tool to create polylines that may be used later for extrusion or profiling. After watching this presentation, you should be able to learn how these basic tools interact with other tools within RealWorks. It's also a step towards advanced modeling in RealWorks. You should also be less intimidated by working with large point clouds. It should give you confidence in pursuing more 3D scanning applications. I'll now show you a live demonstration within RealWorks on how to use these tools. With my points imported, I'll go ahead and use the center on point tool to choose an axis point in order to rotate my data a little bit more efficiently within the 3D view screen. I can then pan by clicking on the center mouse button and rotate my data to a perspective that I can start using the standalone segmentation tool with. Prior to segmenting, you want to make sure that you have the correct object selected by either clicking it within the 3D viewer screen or clicking it within the list view. I'll then open up my segmentation tool by either clicking on Tools in the Segmentation tool or clicking on the Segmentation tool icon on the toolbar above. The Segmentation tool has 3 different methods of segmenting your data. You can use the Polygonal Selection tool, which allows you to select multiple vertices in order to create a polygon. When you hit the space key on your keyboard, it closes the polygon out. You can use a Rectangular Selection tool to create a simple rectangle to select your data, or the Circular Object tool to select a circular area to segment. In this case, I want to use a Polygonal tool to select the area that I want to keep within my segmentation and discard the other area that I want to clean out. Go ahead and make my polygonal selection. There's also the In tool, which will basically preserve anything within that polygon. There's the Out tool that'll get rid of anything that's within that polygon. And if you simply want to create an object based on the polygonal area that you selected, you can create your polygon and hit the Create button. You'll notice that the index or project cloud has about 7 million points. Once I hit the Create button in the Segmentation tool, it'll reduce the project cloud points by the number of points contained within my polygonal frame. I can then rename my object by hitting the F2 key on my keyboard and give it a name that's easily recognizable. Now, although I'm reducing the number of points in my project cloud, I'm not actually deleting them, I'm just reorganizing them. If I want to get those points back for later editing, I can simply right-click on the project cloud and say Get All Points. I can then turn off that main project cloud, and now I'm left with that one object that I segmented out using the standalone segmentation tool. If I turn my main project cloud on, I can see that those points are still there and available for editing later on if I'd like to. Now you can see I still have some noise in my project cloud from the cars that were passing over the scanner while the scan was taking place. So to clean up this noise, I'm going to use the sampling tool located under Tools, Sampling Tool, or you can simply click on the sampling tool icon located on the toolbar above. With the sampling tool open, you can see that I have 6 different methods of sampling. For this example, we're going to use the topography-based sampling tool in order to cut out some of that vertical noise from our point cloud. To make visualizing our cloud a little bit easier, I'll go ahead and change it from scan color to true color. Now within my sampling tool, and most other tools within RealWorks, you'll notice that you have an additional segmentation tool. Instead of segmenting and creating an object, you can actually simply isolate an area of interest that you'd like to sample. You can then isolate that area, exit that segmentation tool, and use the vertical filtering tolerance slider bar to start selecting and erasing unwanted points from your object. You can continue to use the slider bar to refine your point cloud until you're satisfied with the results. You can then reload your reference points, and you can see that you have your edited cloud, and you can continue isolating areas using the built-in segmentation tool and sampling out the noise. The topography-based sampling tool also works really well on some of these sloped edges that have some of this vegetation growing on it. If you continue to follow my simple steps of isolating the object with the built-in segmentation tool, using the vertical filtering tolerance slider bar to erase the points that you don't want, and then reloading your reference points, you can quickly and easily clean up a large amount of data within a pretty huge point cloud. Once you're satisfied with your results, you can click Create and create your sampled point cloud. And you can see the difference between the sampling tool and the standalone segmentation tool is that it's not actually removing any of the points from your project or index clouds. It's creating a sample of the points that you've cleaned up. I'll then go ahead and rename that sampled cloud to something easy to recognize, such as clean overpass. And I can close my sampling tool. I'll now quickly just show you and describe some of the other sampling tools that we have to choose from. We have the random sampling tool that allows us to simply select a percentage or a specific number of points to choose from within our point cloud in order to sample it down a little bit. I can either go by percentage, or in this case I'll choose to keep 10,000 points. I can also increase the size of my points in order to be able to visualize it a little bit more easily. I can go and create that sample and hit the F2 on my keyboard to rename it in the list view. I can go ahead and close out my sampling tool, display and select my clean overpass, reduce the size of my points as they're displayed. open up my sampling tool, and I can also go with spatial sampling, which allows me to reduce the distance between my points within my point cloud. Obviously, I can't increase the density of this point cloud, but I can help to give myself some more evenly spaced points within this cloud. In this case, I'll choose 2 feet between points, click Preview, and you can see that I have more evenly spaced points within my cloud. I can also see that the number of points within my cloud has been reduced pretty significantly. I'll go ahead and rename this object within my list view. Go ahead and turn off my 2-foot point spacing, display and select my clean overpass, and you can see that I have 3 additional methods of sampling available to me. And I'll quickly describe the 3 different methods next. Scan-based sampling allows me to separate my project cloud into the individual scans that may have been captured per station. Intensity-based sampling allows me to use a histogram to isolate certain intensity values and use the remaining points to create a new sampled cloud. In this case, I can take the intensity value from the stripes on the road and create a sampled object out of them. Discontinuity-based sampling allows me to detect edges throughout the point cloud and keep those edges in order to use them within a Polyline drawing tool or to create line work later on. Finally, we'll go over the cutting plane tool as well as the 2D Easy Line tool. I'll reposition my point cloud so I can get a good side view of it. Next, I can open up my cutting plane tool by clicking on Office Survey and choosing Cutting Plane Tool, or by simply clicking on the Cutting Plane Tool icon in the toolbar above. Learning how to project your planes within RealWorks is a vital lesson because you can then understand how to project planes over 3D objects in order to inspect them or to create polylines for, say, extruding or profiling later on. With the cutting plane tool on, you can see that I have a few different ways of defining or projecting my plane. I can either choose the X, Y, or Z axis. And if I wanted to change it to something more familiar, such as northing, eastings, and elevations, I can go to Edit, Preferences, and change my coordinate system to northing, easting, and elevation. You'll now see that my options change from X, Y, Z to the north axis, east axis, and elevation axis. RealWorks also has a pretty amazing ability to fit planes. In this case, I'll select the fitting tool and find the best cross plane across this point cloud. You can see by selecting it, it actually fitted a very nice perpendicular plane to the overpass in my point cloud. I can then use the offset slider bar located within my 3D view to move the plane forward or backward through my point cloud. I can also change the thickness of the sampled slice of the point cloud. For example, if it is set to 5 feet, it's going to give me a sample of that point cloud that was 2.5 feet in front of and 2.5 feet behind my plane. In this case, I can reduce it down to 1 foot, which is going to give me a 1/2 foot in front and a 1/2 foot behind that plane in order to get a good cross-section of the point cloud. I have a few other options for projecting my plane through my cloud. One is to pass through another object's axis, such as another polyline. Another one, which is pretty nice, is the ability to create a plane perpendicular to the 3D view screen. So if I select a perspective from my 3D view screen, I can zoom in a little bit choose 2 points to project that plane. And you can see in the bottom, in the 2D view, it's showing me how that plane is passing through my 3D object. Finally, another method is to choose 3 points to create a plane, and I can do this from any perspective I'd like to. But what I'd like to do now is clear out those planes, close out my cutting plane tool, go and open it back up again to start from scratch. And I want to go ahead and isolate or segment an area that I can get a good cross-section over the upper deck for profiling. I'll isolate that area, and then using my best cross-plane tool, I'll go ahead and project a plane to be able to visualize a nice cross-section in 2D in the screen below. Also change my cloud color to white so it's a little bit easier to visualize that in the 2D screen. I can then open up the 2D EasyLine tool located within the cutting plane tool in order to have the software connect the dots within my point cloud and create a polyline for me if I'd like to. Now the threshold setting is how often the software is going to interpolate between the points in your slice here in order to create a polyline. If I bump that value up to a foot and I preview how that polyline will be created, you'll see that it's creating a line segment about every 1 foot over that point cloud. I could reduce that down to 1/4 of a foot, to 1/10, or an even more refined polyline down to 1/100th. And you can see that it created a refined polyline that connects all the dots within that profile. The only problem is if I want to use this for profiling later on, every vertice or dot to create those lines is going to create an individual profile line. So in this case, I'll go ahead and delete the polyline. I'll go ahead and use my drawing tool in order to create my own polyline. Now every node or vertex within this polyline that you create can become a profile line later on. Once I've selected the last node, I can right-click and say End Line. If I wanted to create a theoretical center line, I can right-click and have the software insert a middle node between the 2 edge of pavement segments. I can then click Apply and create this polyline and slice out of my cloud. I'll go ahead and change my cloud back to true color. Now what can I do with this polyline? As I mentioned, I can use this polyline in the individual nodes in order to create profiling across my point cloud later on. And if I'd like to, I can also use the 2D EasyLine tool in order to edit the polylines or any of the nodes within the polyline. I'll go ahead and save my project. And I can go ahead and turn on and select my clean overpass. Now with the clean overpass selected, I could then go into my Easy Profile tool, and you can see by default under step 1 I had that polyline selected in order to start creating my sampled profiles from. You can see that I can thicken up the step size depending on how detailed I want that profile line to follow the cloud. Go and choose 10 feet and I'll start it. And you can see by using that polyline as a sample or a template of my cloud, it could then detect the edge or the profile throughout that polyline and create those profile lines. I'll go ahead and create those profile lines and close out my Easy Profile tool. And you can now see that I've created profile lines over my point cloud. I'll save my project. Now I can rotate my point cloud within the 3D view, and you can actually see the profile lines that were created by tracing out the point cloud and using the polyline that I created with the 2D EasyLine tool within the cutting plane utility. Finally, I can turn everything back on, and you can see the original point cloud and everything else that was created quickly and easily within RealWorks. If you have any questions or comments, you can feel free to email me at the email address below, visit our website, or subscribe to our channel on YouTube at youtube.com/csdsinc. Thanks for watching.